Hello everybody, thank you for watching. This is our 2.10 half-life video. So in this video, what we're going to do is we're going to understand how long it takes for an unstable nuclei to decay by using half-life. So that's something new that we're going to talk about. So if you remember from our last video when we started talking about unstable nuclei, we know that our unstable nuclei, they decay or they break up into smaller parts. So the real question for this video isn't really what happens, because the reaction tells us what happens and what type of decay it is, but how long does this decay actually take place? So we're going to start with 80 grams of TH, and this is element thorium, and it's going to be an unstable nuclei. So we know that we have 80 grams of thorium. So the key thing is this. We're going to learn about what nuclear half-life is. So nuclear half-life is the time required for half of the nuclei in a sample to decay. All right, so if we start with 80 grams of thorium, in order for half of thorium to decay, it's going to take a certain number of time. And that time is called half-life. And this right here is the symbol for half-life. T with the little subscript 1/2. So what that means is this is the time it takes for half of a sample to decay. So let's say, for instance, the half-life for thorium is 25 days. So our T 1/2 equals 25 days. So what that means is it takes 25 days for 80 grams to turn into 40 grams, where half of it is being decayed. It takes another 25 days for our 40 grams to just decay half again. So we're left with 20 grams. And then it takes another 25 days for it to decay again. And then our 10 gram sample that we have left is going to decay again. And it's going to take another 25 days. So each time this sample decays in half, it requires a specific amount of time. And that's what we call half-life. So if you think about it, how long does it take for thorium to decay up to 5 grams? We have 25 days for each half-life. So this sample underwent 4 half-lives. So 25 days times 4 half-lives, you can see that it is going to take about 100 days for the sample to decay up to 5 grams. So again, the half-life is the time required for half the sample to decay. So if you think about thorium, when it does not undergo any half-life, we have 100% of that sample left. When it decays and it undergoes one half-life, half of the sample is gone, so we end up with 50%. When this undergoes another half-life, we have 25%, another one, 12.5%, and so on and so forth. So as time goes by, you can see your samples are being decayed by half. That's why you call it half-life. So one thing that's really important, if you look at this table, you can see that these are multiple isotopes of different types of elements. The half-lives actually are very different for each isotope. So different elements and isotopes have different half-lives depending on the stability of the nuclei, because each of these nuclei have different types of stability, whether they're larger or smaller nuclei, and the type of radiation that is emitted. So hopefully in this video you got a quick recap of what is nuclear half-life. Stay tuned for the next video to learn how to do half-life example problems. Thank you for watching.